Good afternoon, dear guests. Welcome you all. My name is Tuğçe Yüksel. I am a faculty member in Faculty of Engineering and Natural Sciences. I am also a committee member in the rewards committee in our faculty, who is organizing this event. So on behalf of our faculty and committee, I would like to welcome you once more to our second 3-minute thesis competition. The first one we held last year. This is our second time, and we are very excited to be holding this event second time in our campus. So before the presentation starts, before the actual fun starts, I would like to give you a very brief overview of this competition, as well as the event that we will have here today. So 3-minute thesis competition is a research communication competition. We emphasize this a lot because here we are not evaluating the quality of the research. We are evaluating the quality of how good the research is being conducted to the audience. Here, the idea is PhD students have 3 minutes and a single static slide to present their thesis and its significance. Our aim here is to challenge the students to consolidate their ideas as well as their research discoveries so that they can be presented concisely to an audience who are not necessarily a specialist in the area. This competition was first developed by University of Queensland in Australia. Actually, they hold the brand name right for this competition, so you have to take their official permission to hold this event in your institution. But it is implemented by many universities worldwide. Actually, when I checked the current numbers, more than 600 universities worldwide is holding this competition. And last year, we joined these universities. We are the first and only university from Turkey joining this network. And why did we want to hold this event for the first place? Well, first of all, we wanted to have an event for our students to improve their presentation and research communication skills, as well as we wanted them to look at their research, what they are doing from a high-level perspective. And we wanted them to train themselves for explaining their research in a limited time to a non-specialized audience. In addition to that, we wanted to have an event in our faculty where we can celebrate the innovative research we are having and where we can enhance the interaction. To do this, we were looking for an informative and entertaining event, and 3-minute thesis satisfies all of these requirements perfectly, actually. Now, what are the rules? Our presenters, our competitors will have 3 minutes to present their work in using only a single static PowerPoint slide. They have 3 minutes maximum, and this is very strict. If they pass the 3 minutes limits, unfortunately, they will be disqualified. We won't be stopping our speakers. We will let them finish their sentences. However, as soon as they start talking, you will see on the top hand corner of their talk, there will be a clock, a countdown will begin. So that's how we are going to measure their time. And also they will have a timer in front of them so that they can follow how they are doing on time. And they are not allowed to use any additional electronic material. And the decision of our judging panel will be final. And speaking of our judging panel, we are very privileged to have very valuable jury members with us here today. Professor Shirin Tekinay, our Vice President, Murat Germen, faculty member from Faculty of Arts and Social Sciences, also artist and photographer. Sait Olmaz, faculty member from Engineering and Natural Sciences, also the Director of Graduate Programs in Information Technologies and Data Analysis. We have Arjan Varlıbaş with us. He's the founder and CEO of VSY Biotechnology. And we have Kozan Demircan, who is a digital transformation consultant, as well as a lecturer at Bilgi and Bahçeşehir University. I would like to thank all of our jury members once more for joining us and supporting us here today. But our jury members are not the only ones who will be casting votes today. Actually, we have a category, People's Choice Award category, which will be the recipient of which will be determined by you, by the audience. For this, at the end of the event, we will share with you a link to a website where you can log in using your Sabancı University credentials. And once you log into our system, you will first see an introductory page which gives you a description about the evaluation criteria. And once you proceed, you will have a second page where you will see the names of all of our competitors as well as their talk titles. And you can select the one speaker among them who you think should be receiving this award. Now, you will be allowed to log into this system only after all the talks are over. You will be able to log in only once, and you will be able to only vote for one person. And we will inform you after the talks are over about this website once more. So what will be the judging criteria based on? Well, we have two categories. Under the comprehension and content, we are most interested in if the presentation helped the audience to understand the research, as well as it's significant, and if the presentation was in a language appropriate to an intelligent but non-specialist person to understand about the research. We have another category, which is the engagement and communication community. And here we are interested in seeing if this oration make the audience want to know more, and if the speaker had enough sufficient stage presence, eye contact, and vocal range, and basically how did they do on the stage. A few other notes, you and our jury members will be evaluating our speakers based on their 3 minutes performances only. We won't be getting any questions. There won't be any question and answer sessions because, as I said, this is all about those 3 minutes. However, we will have a coffee break in between and also eventually at the end. So during those times, if you're interested in a topic one presenter talked about, please find that speaker and talk more about it. One of the purposes of this event is this, to enhance the interaction inside the faculty. Also, we will invite each speaker one by one to the stage, and between each speaker, there will be a few seconds of pause for our jury members to finish evaluations for the previous speaker. And of course, the awards. We will have a winner and runner-up determined by our jury members. The winner will receive 2,500 Turkish liras, whereas the runner-up will receive 1,500 Turkish liras. And the recipient of the People's Choice Award will get a 750 Turkish liras. Now, in the case that the winner and the People's Choice Award goes to the same person, since we want more people to receive awards, we will go to the runner-up of the People's Choice Award recipient. We will acknowledge the fact that, that the winner, for example, got the most votes, but the award will go to the second person in line in terms of the votes for People's Choice. And finally, here is our program today. So after me, we will begin with our first group of speakers. There has been a slight change in program. Unfortunately, one of our speakers couldn't make it today, so we will have 11 speakers. We will first listen to the first 6 speakers. After that, we will have a 10-minute coffee break. Then we will continue with second group of presentations. After all these talks finish, we will have, again, another 15-minute break for our jury members to deliberate and also for you to cast your votes for the People's Choice Award. Once again, we will share with you the website, link to the website, as well as a QR code, which you can log into. And once we determine our award recipients, we will announce the winners and we will conclude with the award ceremony. Okay, without further delay, I would like to invite Banu Akıncı, who will be presenting our speakers to you today. Once again, thank you for coming, joining us today, and I hope you will enjoy the event. Thank you.
Good afternoon. Welcome again. Without any further delay, I would like to invite our first speaker, Adnan Taşdemir. He is from Material Science and Engineering program, and he will present us future battery technology for vehicle electrification, lithium-air battery.
Hello, everyone. As you all know, our main energy sources are fossil fuels.
Adnan, once.
Nice.
The timer. Now we can. Yes.
Hello, everyone. As you all know, our main energy sources are fossil fuels, and which is gasoline, petroleum, and coal. But there is a problem with that. Scientists predict that these energy sources will be depleted in the next century. So, besides that, these fossil fuels has detrimental effect on the environment by polluting the air and emitting the greenhouse gases. We have reached a critical point due to these emitted greenhouse gases, which is causing global warming. Besides all that, energy consumption rises exponentially. And we somehow have a green renewable technology to compensate this problem, which is solar, wind, and ocean tide. But they are not available every time. So to deal with this problem, industry or the modern society needs some devices to store the energy and deliver that energy which powering the electronic vehicle. So according to that graph, as you can see, we have technologies like lithium-ion batteries, fuel cells, and spare capacitors. But especially with lithium-ion batteries, you are able to carry electronic devices in your pocket. But let me ask you a question. Are they good enough to power our automobiles? Or asking differently, can they compete with internal combustion engine in the cars? Well, the answer is no, because as you see in the graph, the energy and power density of them is not close to internal combustion engine in the cars. We have a new technology, lithium-ion air batteries, that have these values and competing to the gasoline that providing energy to our cars. So imagine that you have a battery, you need to just charge it in 10 days period, and when you charge it, it will take just 6 minutes. So we are very close to this. So as you see, there is this small difference with the lithium-ion batteries and lithium-air batteries. Lithium-air batteries is open system and that can use oxygen from the air, which convert it to the energy and deliver more energy to the system. So, but to be honest, there is problem with this life cycle. The material that I produce can go over this problem and having the longer lifespan of these batteries. So by my material, we can have an environmentally friendly green technology lasting long, and the energy demand will be no problem in the future. Thank you.
Thanks, Adnan. Next presentation will be given by Ali Askarpov from Physics Department. He will present us spin transistor based on exotic materials.
Do you remember floppy disk and how many of them we needed to store some information, or for installing a game or software on our computers? Nowadays, we are using some other storage devices like the flash USB and SD cards in our cameras. So we have seen a lot of change in the electronic devices in terms of the size and memory. So each transistor in electronic devices role is that for storing the information. But the technology reached the ultimate physical limit, which we cannot go further. So we cannot have smaller devices if we do not find another option for having the memory devices. So what we do is adding the spins of the electron, which is an intrinsic feature. When we reach the smaller scale, we are entering the new world, which is called quantum. So we can apply them and then introduce a spin transistor, the transistor which are working based on the intrinsic features. You cannot consider what is the spin. The spin is something like the small tiny magnets which has a polarization to the north or south pole. And also people in the world trying to use the ferromagnetic materials like the iron and nickel, but after using a lot, they are gonna deteriorate it. So, but we used some exotic materials which just by attaching a battery to them, we can have a current on the surfaces leading to a spin accumulation. Then we can extract these spin accumulation to be a source of the spin current. The spin current is the flowing of the electron, which they have the specific polarization. And another thing, not only that we can have the smaller devices, but also in the terms of the energy, that you cannot imagine that how we can use less power about it. The energy that we needed to turn on and off a transistor decreased by 99.9%. And whenever the spin transistor is on or off, we do not have any power dissipation. So we can have faster, low power without any dissipation, and the smaller devices which we can reach to just less than nanometer two in our future. And and another thing that I want to mention about that, how we can fast to transform our data. Nowadays that you can see that you should wait a lot of minutes for transferring your data from a USB to a computer. As Martin Teller, physicist, said, the science of today is the technology of tomorrow. Thanks.
Thanks, Ali. Atiye Shafik from Electronics Engineering program will present us her talk titled See the Unseen.
We can all see very well during the day because of the light. We see very little in the night due to darkness. And I'm sure, like me, myself, most of you, any time in your life, must have been afraid of darkness because it limits our vision. But what if we get an infrared camera with us, which can let us see, like this minion over here, and let you see through the darkness? These infrared cameras are not only used by military for the border protection and safety and during the warfare time, but we need all these security and safeties in our home, in our workplaces, while walking in the crowded and narrow streets in Istanbul, while driving on the forest, or even to see if your food is cooked in the microwave. But how does that work? So everything around us, even in this room, is emitting the thermal radiation, which mostly comprises of the infrared energy. But Our eye cannot see that light, but the infrared camera can see that. And the detector inside the infrared camera basically collects this infrared energy, convert into the electrical signal, and process with the electronics to reproduce the image of the scene. The quality of this infrared image mainly depends on how well your detector can differentiate between the temperature difference of the object present in that scene, which is, in other words, called as the thermal sensitivity of the detector. To improve the thermal sensitivity of the detector, we need to come up with the innovative materials to enhance the thermal sensitivity. In our research, we are mainly focused on developing infrared detector based on silicon. Why silicon? Because it's a backbone of today's microelectronics industry. It's cheap and it's easy to process. But in order to enhance, particularly we are analyzing how to enhance the thermal sensitivity of silicon by adding germanium into it. You add more germanium, you get more sensitive material, but nothing comes for free in life. So adding germanium into silicon causes some problems in the material itself. It may bring the defects, which can lead to the poor image quality. Well, so in my research, we are trying to analyze through simulation and device modeling and lab testing that how much amount of the germanium has to be added into the silicon in order to make a more thermally sensitive detector. Well, after all, who don't want to see the unseen and feel safe and secure? But be aware that we don't want to spy on our neighbors. Thank you.
Babar. Okay. Now we will listen to Babar Hussein from Molecular Biology, Genetics and Bioengineering program. He will present us development of salt-tolerant wheat.
Ladies and gentlemen, more than 1 billion hectares of land in our world is under salt stress. So what does it mean? It means we cannot grow almost 80% of the crops there. Even we grow some crops there, they will have reduced yield. Means we will have less food to eat, less cookies, everything. I mean, because mostly rice, wheat, our major crops, most of them are highly salt susceptible. On the other hand, there is population explosion, and by 2050, we will be 8.5 billion people. It's large, like more than 1 billion in coming 30 years. So where the food which we feed these people will come from? Definitely from this area. How? You know, in past, we have seen a lot of famines in African countries, in Bengal, in Ireland, due to the failure of a particular crop or many crops. So we have seen people suffering from malnutrition as well. But we have a solution, ladies and gentlemen. That is that if we can use this soil, how we can use this soil? Either we can correct this soil, how? We can just grow such few useless crops which yield no food to human beings for years, like 20 years, 30 years, and later get food. No, because we cannot wait so long. The population will almost go double in this. So we have developed, to cope this, we have developed a wheat here by using genomics knowledge. We have identified 49 QTLs. We have identified more than 1,000 transcriptional factors and genes which confer salt tolerance to wheat. So our selected plants, you can see on the right side, can grow on 300 millimolar salt stress, which is almost equal to 50% seawater. What does it mean? It means that our research will lead to development of such crops which can be fed to thousands, even millions of people, and can fight hunger, can make the people healthy, can provide them the food, can have a great socioeconomic impact on the farmers as they will get more yield and ultimately, if a farmer of a country is happy, that country has a strong economy. On the other side, this means that we can use these crops and we can provide seawater for growing these crops, and we can save water worth of billions of water, because the next wars will not be fought for anything but water. So it will contribute greatly. Thanks a lot.
Thanks, Baba. Now we will listen to Didem Özkazanç from Molecular Biology, Genetics and Bioengineering program. She will present us Generating Super Soldiers Against Cancer, a Cure Within.
Did you know that you started this day by producing 50 million new cells every second? Every second, you take apart your genetic code in 50 million cells. And I'm telling you, with so many cells to duplicate, it will make some errors. And at the end of this day, you'll develop about 1 million cells with errors, false productions that we call cancer cells. But don't worry, because your immune system cells are there to protect you. They scan the faces of the victim and the perpetrator, and if they recognize certain molecules on their surfaces, such as nose and eyes, as self, they don't get alert. But certain molecules on cancer cells sense the immune system, eliminate the target alert. This is how they recognize and beat up the enemy for you. But there are cells of my favorite, the immune system cells that are actually called natural killer cells that circulate in your body and born to kill them for you on the first round. However, some cancer cells wear disguise, mask themselves with don't beat me up molecules. Hence, cancer cells that once could be identified by natural killers now escape from the elimination, which present itself as tumors big enough to create detectable health problems. And when this happens, your body needs just a little bit of an extra help, and this is where my research steps in. What I find fascinating is that despite the cells in disguise, your own natural killer cells are able to fight the good fight for you. So, you see, I'm interested in finding the ways to harness their powers. In my PhD studies, I will genetically engineer the natural killer cells to have more of the same molecule, to generate super soldiers. This way, but what's more, the cancer cells in disguise have different molecules, just like characters, and they are rather unique in each patient. So we need a patient-specific screening system, just like a special ring, where on one corner there will be a cancer cell from one unique patient, and on the other, there will be one of each super soldiers. At the end of all the rounds, we'll see which superpower will work the best for that unique patient and genetically modify the patient's own natural killers to beat up the cancer. Once my analyses are complete, I'll be able to optimize a screening tool that can be used in hospitals. This way, my thesis will show a patient-tailored solution without having to know the cure, but the right soldier we need. In the end, we all have superpowers within. Thank you.
Thank you for your presentation, Didem. Low Reynolds number swimming of chiral and axisymmetric structures will be presented by Ebru Demir from Mechatronics Engineering program.
As you know, cancer is one of the causes that cause. I'm sorry. As you know, cancer is one of the diseases that kill most of the people all over the world, and this is a huge problem. Not just because cancer itself is highly invasive and very dangerous disease, but also because of the treatment protocols involved with curing the cancer. You are giving your system highly toxic drugs that will affect your healthy cells as much as your sick cells that are disease-ridden. So what if we could get rid of this problem? What if we could get rid of the side effects? There would be another advantage to this also, because if you could deliver the drugs only to the sick cells, you could increase the dosage you would use, thus giving hope to the patients that would be so far hopeless with the existing power of the drugs. So to overcome this problem, researchers thought of something. They thought if we could have tiny swimmers that you can put inside your body through your veins, make them swim all the way to the tumors or the disease-ridden parts of your body, and give the drugs only those parts, you would have no problem with your healthy cells, right? But this solution has a challenge, because when you go to so small scales, physics of swimming changes entirely. What would feel for us to be swimming inside water would feel like swimming inside honey or something stronger for these tiny structures. But luckily for us, nature presents a solution. Look at these bacteria and spermatozoa cells. They have helical structures behind themselves. They use them to propel themselves inside viscous fluids. But as scientists, we can replicate those. But there's another problem with that, unfortunately, because creating such intricate structures inside the lab environment is very expensive, requires very much time. You have to be very precise, and you have to use expensive equipment. It consumes your time, also consumes your money. Now, what if we could have a device that would tell us how well our microswimmer would perform in such an environment? What if we could test our designs prior to manufacture, thus reducing the time and cost to manufacture them? Part of my thesis focuses on this. We have devised a computer simulation program that could analyze any helical structure of any cross-sectional area just under 2 minutes using a common laptop. Also, we use these simulations and also lab testing to come up with guidelines for the researchers to optimize their swimmer designs, thus making swimmers of higher velocity or higher efficiency, higher energy efficiency, without harming the body. Hopefully, my research findings will help these researchers to come up with a smart, targeted delivery system and help millions around the world. Thank you.
We would like to thank Ebru for her presentation. Now we will have a coffee break, 10 minutes coffee break. After the break, we will continue with your presentations. Okay. We will continue with Farhan Ahmed from Industrial Engineering Program. He will present Computing with Words from Linguistic Preferences to Decisions.
Okay. So we make decisions every single day of our lives. And knowingly or unknowingly, we often use linguistic preferences to make these decisions. So first of all, what are these linguistic preferences? Let's say we have to choose an automobile car, and our choice will be based on various different criteria, such as price of the car, color of the car, engine power, and various others. And we can provide our preferences, such as price is strongly more important than color. So in this statement, strongly more important is the linguistic preference. Now, in the literature, there is a consensus that humans or people are more accurate and more comfortable when they provide their preferences in these natural language phrases. So this information in qualitative form, we cannot use them. So these linguistic preferences is a scale of 1 to 9. Let's say again this phrase, strongly more important, would correspond to a number 5 in the scale of 1 to 9. And similarly, other phrases would have the similar meaning. So once we transform this information, this linguistic preferences into numbers, then we can use them in various different decision tools such as AHP to make more structured decisions. Now, my research basically critiques this transformation of linguistic preferences because this assumes that when these natural language phrases have the same meaning for all individuals. That is to say, when I say strongly more important, it has the same mathematical meaning when any one of you says strongly more important. So this doesn't make sense. So based on this, various different methods, which are based on mathematical modeling approach, some AI techniques such as neural networks, and some heuristics, which will take these linguistic preferences in the form of words as inputs, and it will give me a numerical scale which will be optimized at an individual level. So for example, the same linguistic preference such as strongly more important would have a meaning mathematically 4.1 for one individual and maybe 6.2 or 6.3 for another individual. So it will be individualized, it will be optimized at the individual level. Now this research does not, beyond decision making, this research has some other applications as well. So as we move towards the 4th industrial revolution and our communication with machines becomes more frequent, so this research will be able to, will help machines actually better interpret human preferences. For example, there's a robot shown here. It's a social robot. It learns from your preferences, and it makes communication with humans more meaningful. So with this example, I'm going to conclude my presentation. Thank you very much for listening.
Hanifi Marjan from Computer Science and Engineering Program will present us Unified Combinatorial Interaction Testing.
Okay, National Institute of Standard and Technology reported that more than $60 billion cost for only software for fault detection. So therefore, just for fault detection or in general software testing, plays an important role for quality assurance. Okay, first of all, let's see how the software testing works in general. First of all, we call the developers working in the field as practitioners, and practitioners, you can see one example from here, from there. She develops an application or software system, and when she wants to test her system, she uses generally the same tools and same algorithms to test her system. But when she needs something more, where we call that new coverage criteria, that's the part we involve as researchers. We take these new coverage criteria and try to generate a test suite for that software system and tell the practitioner, if you want to get coverage A, you need to use tool A. Then after a while, she wants more and try to cover her system with coverage criteria B. And we take this again as a problem and study it and try to develop new algorithms, new tools, and tell the practitioner that is the thing you need to use. And again, it works same with coverage criteria AB. We tell the practitioner you need to use tool AB. Okay, this phenomenon has continued for decades, and it will most likely continue for several decades as well. So we are planning. What we want to do is to break this loop. We are planning to define a new language only specific for software language, and with this language, we will enable practitioners to define their own coverage criteria and own software system, so that the test suite will be automatically generated our unified tool. And we will accomplish that trying to convert each coverage criteria into a problem that we know of very well, and all the remaining part is just try to solve this common problem. And a good part of this approach is, even though if we encounter a completely new coverage criteria in the field, all we need to do is define a new mapping system, and the rest will be done our tool. So in conclusion, we could say that our biggest aim is to develop a new language for software testing, and when the practitioner will use this testing, and all she needs to do is to define their own software system or coverage criteria, and our tool, our unified tool, will generate automatically the test suite that she wants. Thank you.
Sofia Pierpoli from Molecular Biology, Genetics and Bioengineering program will present us her talk titled Crystals Are a Girl's Best Friend.
Cancer has a huge impact on our society. Approximately 40% of all people will be diagnosed with cancer at some point during their lifetime. Almost 20% of all death in Turkey is still caused by cancers. Maybe these are numbers that you can also figure out on your own. But what you probably don't know is that for about 50% of all known cancer types, the main responsible is the malfunctioning of only one protein, p53. Now imagine all these p53 molecules. They're like the guardians of the cells. They take care of the health of our DNA. But who controls their activity? Who watch the watchers? We discovered the protein, one of the proteins that controls p53 activity in cancer pathways. This protein is called PAX1. And besides regulating p53, it's also very important for cell growth in our immune system, and it's involved in several different cancers. PAX1 does all this because of the high potential of its structure to communicate, to interact with other proteins. You have to imagine proteins like chains of smaller particles, like pearls in a necklace, that are organized in a 3D shape or structure, and they are mobile. What I do for PAX1 is to observe the structure and try to understand it. First of all, in order to see a protein structure, I need to induce some simple bacterial cells to produce this protein for me. Then, once extract and purify it, I leave it rest for some days in a solution. As the protein molecules precipitate at the bottom of the plate, they accumulate in some beautiful shapes that we call crystals. Then, with a technique known as X-ray crystallography, we make use of extremely powerful beams of light to literally see to the smallest details how the protein structure looks like at the atomic level. Being able to see a protein structure makes it possible to study how it works and how it moves, because its dynamics in space reveals the mechanism of action and how it can actually interact with other proteins. Finding the key interactions for PATS1 is my goal, and this will contribute to understand how cancer develops at cellular level and how we can intervene to lower the impact of cancer on our society. Thank you.
Now I would like to invite Yonca Belce from Material Science and Engineering program. She will present us controllable capsules among layers on bandages.
In the past decade, the number of new skin cancer cases diagnosed annually has increased by 53%. In addition to current technologies, there is an ongoing demand for new cancer treatment methods. Photodynamic therapy is one of the promising cancer treatment methods in recent years. It's non-invasive, it doesn't require any surgical operation, it's a repeatable process, and it is positively tolerated by patients, especially for those who are at their early cancer stage. So, what if you would have a chance to transfer the drug immediately directly to the degenerated region, rather than taking pills and waiting for it to be activated? We all want higher and faster efficiencies and low toxic effects in our medical treatments, right? So let me tell you a method which enables to transfer the drug molecule among biocompatible sheets or layers. So it is called the layer-by-layer coating technology. So in my research, I'm applying layer-by-layer coating technology to apply local photodynamic therapy purposes. But of course, there are several other application areas of layer-by-layer coating method as well. So in my case, first, I'm spraying out a functional coating material on top of a surface of bandage, rinsing it with water to get rid of the excess material. Then I'm spraying out my second functional coating material, which is basically made of the drug-containing capsules so that they can interact with each other. So at the end, once you activate these drugs by light, they are ready to cure you. So compared to other coating technologies, layer-by-layer coating technology has significant advantages. So first of all, you can control the material amount on surface in terms of concentration and distribution, plus you can control the material amount you degrade from the surface layer by layer as well. Secondly, it's a completely water-based system, so you don't need any chemical solvents, so it's definitely environmental friendly. Last but not the least, it's a simple, gentle, and versatile technique. So in the near future, you may not need any drugs to swallow if you have a skin-oriented disorder. Drug-containing capsules with controlled amount of material and distribution on such bandages will bring a new life to skin cancer patients in a simple, harmless, and gentle way. Thank you.
Thank you, Yonca, for your presentation. So with this presentation, we come to the end of our talks. Unfortunately, one of our competitors couldn't make it today. So I would like to thank all of our speakers. Now we will have another break for our jury to go over their votes. Also, we would like you to log in to our web form. You can either use the QR code here. We tested it before, it should be working. But if it doesn't, you can also use this website link that you see here. Once again, once you log in, or once you enter the website, you will need to log in using your Sabancı University credentials. And then first you will see a page which is giving you evaluation criteria. If you say next, you will be able to see the list of the speakers. and you will be only allowed to vote for one speaker. So with this, we will take a 10-minute break. Once you cast your vote, you can again go outside, enjoy a coffee break, and after that, we will come back for the awards ceremony. Excuse me, I think a few people had problems logging in through Android. So in your Android, you need to also add your Sabancı account to the system. So in your Google accounts, you have to add another account, which is your Sabancı University account.
Oylamayı kapatıyor muyuz? Daha devam edelim.
Ercan Varlıbaş.
Ercan. 6-5. 6-7.
Şimdi sonraki geçti değil mi? 6-7.
7-8. 7-8. 7-7.
Bir dakika 7-8. 7-7. Didem 7-7. Ebru.
Ebru 7-6.
Hı hı.
Baran 6-6. Hanifi 6-5. İlknur'u geçiyoruz. Sofya
İki tane runner-up var.
Okey, eşit yani.
Hı hı.
Hala çocuğu verecek misin? Bence şey
Ne
yok, bir
yapalım?
tane seçimleri rica ederim. Bir tane seçimleri rica ederim. Kim o? Closing the poll system for people's choice. Just to inform you if you haven't voted or if you are voting. Okay.
Ya sonuçta
Sormamı Okay, dear guests, welcome back again. So we come to the most exciting part, award ceremony. But before going into that, I would like to thank all of our competitors once more. You did a great job. Thank you for joining this event. Okay. So, oh, this was fast. Okay. I would like to invite one of our guests, Mr. Kozan Demircan, on stage, please, to give the People's Choice Award to Ali. Congratulations, Ali. Thank you very much, Mr. Demircan. Now we will proceed with the runner-up. For that, may I ask Mr. Ercan Varlıbaş on stage, please, both for the announcement and also for presenting the award. Okay. So the recipient of the runner-up award is Atiye Şokek. Thank you very much. Okay, now it's time for the winner, and for that, I would like to invite Professor Tekinay on stage, please, to present the award of the winner.
I'm instructed to have the attention, the suspense climb, so I will say a few words that I'm extremely proud to be here, proud to know each and every one of you and to listen to these wonderful dissertations. And I do wish there was more than 3 minutes for each one of you. Anywho, without further ado, may I? The best of this year's 3-minute thesis award goes to Ms. Ebru Demir.
I would like to acknowledge one fact, as I said at the very beginning. If the winner and the People's Choice Award was the same person, we would proceed with the runner of People's Choice. So I have to acknowledge this. Ebru was also the recipient of the most votes from the people, from the audience too. So congratulations once more. But it was a very close race. I have to say that. It was a very close race. We will announce the results on our website too. It was a close race. So once again, congratulations to you all. Now we would like to invite all our jury members on stage again, if you mind. And we would like to present you a small token for our appreciation. Thank you very much for joining us today. And then we would like to take a few pictures with jury members and with our competitors, if you mind. Thank you. Ozan Bey, çok teşekkür ederiz. Ben şimdi girmesem de olur, sonra girerim. So we have certificates and small gifts for all our competitors. I don't want to take everyone's time by presenting it one by one, but please make sure that you receive those before you leave. Okay, thank you very much for your attendance. And thank you all for coming and supporting.
We can. One more photo.
Biraz şöyle de açılabiliriz.
Thank you.
Ne oldu? Evet.